So hello guys, welcome back to another video, and today we have a very interesting problem on number of roots. So basically in this question we have to find that how many real roots of this equation exist. Okay, so you can pause the video and give it a shot, and then you can come back later and see the whole solution. Alright, so I hope you would have given it a serious try, and let's see how we are going to solve it. So first we see that there is an equation that is given and there are a lot of mods that is being used, right? Alright, so let's suppose that if you want to break the mods, okay, so if I want to break let's say this mod, okay, so let's say I want to put a okay, wait, I'm missing this yeah, there is one more, this closing mod, right? Okay, so if I want to break this mod, then I would simply put a condition x greater than 2, right? And how will it break? It will break like 3 to the power x, x minus 2 minus 1 is equal to 0, right? Now let's suppose, how do we find that what are the number of the roots of this equation? So we will basically use the analytical method, the analysis of this equation, okay? The analysis of the graphs and how it when it crosses the x-axis, right? So that is the main idea. All right, so let's begin. Like first let's see the value. Let's say I am calling this whole thing as fx, okay? So what is f2? What is f2? F2 is equal to, if you see that this is going to be 0, right? You can see that. So this is minus 1. What is f infinity? What is f infinity? So you can see, okay, wait, you can see f infinity is equal to, this one will go, this one will go infinity, right? And this one will also blow up to infinity. So this will go to infinity, right? Great. All right, so this is minus 1, this is infinity. So there is definitely one solution between 2 to infinity, right? So graph is something like this. If I show you, graph would be something like this. Like let's say here it is 2, right? Here it is 2. So for 2 it is negative 1, and here it would somewhere it will cross this x-axis. So there is a root, okay? All right, so one solution is there. Now let's suppose that, okay, let's view like this. What is f dash x? What is f dash x? F dash x would be ln 3 x minus 2. Why? Because you can see 3 to the power x, so we will first differentiate this part, that would be x1, and then a to the power x differentiation is ax ln a. Let me write that formula for you. So basically the formula goes like this. Let me write with this one, okay? So if we have a to the power x, then that is derivative, if we want to take like this is the formula. I'm using it for derivative of 3 to the power x, okay? All right, so yeah, now let's see that if you see this, so for x greater than 2 we are talking about, right? For x greater than 2 we are talking about, and when it will be like, can we solve this equation? Like, so if we put if we get the 3 to the power x as common and out, then we have 1 minus ln 3 x minus 2, right? Okay, so that gives us x minus 2 is equal to minus 1 by ln 3, right? Okay, now x is equal to 2 minus 1 by ln 3, right? So this we see that this is something which is less than 2. 2 is here and something which is less than 2, right? Okay, so that would be not, that will not come in this domain, right? So this root here, this root is invalid for the current domain, okay? So what does this tells us? This tells us that f dash x is not going to be 0 anywhere, and that is why the graph that we made here, that is why the graph that we made, this one, this graph here, okay, as you can see from the highlighter, this graph that we made here is right, because it will only cross the x-axis at one time, and the slope of this function, the slope of this fx, that is always positive, okay, that is always positive. Otherwise, what could have been another possible thing, that let's suppose that f dash x has some roots in between, okay? So let me draw it for you. If it has some roots in between, then it may happen that it goes like this and may again come down and again go increases. So there would be multiple roots. But right now it's not happening, right? So there would be only one root for x greater than 2. Alright. Now, as you can see, what would be some other ways that we can break the mods? So let's say if x is less than 2, then how the mod will be broken? Okay. Alright. How the mod will be broken for case number 2, x is less than 2. Now right now we are not dealing with x less than 0. We are only considering for x greater than 0, because that is how for x greater than 0 and x less than 0 this mod will be broken, right? We will not be worried about that right now. So let's say for x less than 2, fx would look something like fx would look something like 3 to the power x 2 minus x minus 1 is equal to 0. F dash x is equal to, we will do again the same analysis, right? 3x ln 3 2, 2 minus x minus 1, then 3 to the power x 1, I'm just taking the common, ln 3 x minus 2, and when does this, this one would be this bracket, right? That goes to 0. So that happens at x is equal to 2 minus 1 by ln 3, right? Okay. And so that is 2 minus 1 by ln 3, and this is basically one root, right? This is basically one root. So if we see that around this 2, the slope is positive, right? For this whole thing that we have done the analysis here, that around 2 the slope is positive only, and then in between it is going to be negative, because 2 minus 1 by ln 3 is a root. So here let's say 2 minus 1 by ln 3 is here, and let's say here it is 0. Okay, so here in this part it would be negative, right? In this part it would be negative. Okay, great. And we are not going to do the analysis after that, right? So it looks like that the graph of fx is something like this. Let me draw it something like this. Like, let's say 2 is here, and let me take this. So for 2 it is negative, it would cross some here, okay, and here it would be, here the slope actually that is decreasing, and then it begins to increase at some point of time, right? Because this point is actually, this point that I'm highlighting is 2 minus 1 by ln 3. Okay, because this is where the slope is 0, right? The slope is 0. The slope is 0 means the tangent that has a slope 0, right? Okay, and then it would be like negative for forever. For up till 0 it would be, the slope is negative only. So you can see this is for the negative graph slope, right? Okay, so we got one root for the slope. That means it would be cross. Okay, now if you see that, how do I know that f0, why I have made it to the positive side, right? So if you see what is, let's say here what it is. What is f, let's say 0 only. What is f0? That is, if you see this is 3 to the power 0, that is 2 minus 1, that is greater than 0, right? And as we know that f2 was less than 0 from the previous analysis. So this is, of course, this would be on the positive side. So it is, this graph is crossing the x-axis twice, right? It is crossing the x-axis twice. And what is this analysis? This analysis is for x greater than 0. Okay, wait, this UI actually is troubling me a little bit. So this is x is greater than 0, and it has two solutions, this fx, right? So if we are using mod x, then we know one thing, that if there is mod x instead of simply x, then the right side of this, right side of the y-axis, the nature of the graph, it is simply replicated on the left side also, right? Wait, it is simply replicated on the left side. It's not very up to the mark, but that is how it would look like. This line is black. Okay, so we have, let's say 1 2 3 and 4. Okay, All right. Why this happens, I will give you just a little bit of hint that why the mod x graph actually it's just a replicate. Give you a little bit of perspective on this idea. The idea is that let's say this is the graph, okay, like this, and let's say I am having like this is 0 comma 1, and this point is 1 comma 2, this point is 3 comma 0, and let's say this point is 4 comma minus 1, like this, okay. And this is some graph of fx, some weird fx, and we have defined that x is greater than 0. So let's say we want the graph of f of mod x, and so how would we get it? So for x greater than 0 we already have fx. What is on the negative side, like what will happen on the x that is less than 0, right? So like if we plug in here, let's say -1 or -3, then will it not become eventually f1 and f3? And what are the values of f1 and f3? 2, 0, same with the 0. If we plug the 0, then the value is 1. If we plug 4, then value is -1. So if we plug -4, then the value is again -1. So simply the graph will be replicated. Okay, the graph gets replicated, and as you can see here, as you can see in the upward, what do we have? It's like f of mod of x, right? So that is the reason we are getting 4 solutions. Okay, 4 total number of solutions. So the answer for the above problem is 4, right? Great. Okay, now let me show you the wizard method. Okay, wizard method. How would a math wizard solve it? Wizard method. In fact, I would like to highlight it. So this is a very like I would say you can use it as a trick or a better method to solve a math problem quickly, of such kind of problems where the question asks about the number of roots. Okay, number of roots of a source. So as we see, like let me rewrite the problem for you. 3 to the power mod x 2 minus mod x, and this is inside. Yeah. So if you take like, let's suppose this approach basically involves that we want to see the number of roots by making the graphs. Okay, so which graphs are we able to make? Like in these kind of problems, I would like to give you a, let's call it PST, problem solving technique, that you have to know and you have to figure it out, like what graphs do you know and what graphs could you make easily. Like making this graph is quite difficult, right? You can't just equate it to one, right? So what the idea is basically here, that you make the graph of this. Can you do it? What is the graph of the on the RHS side? So if we would having 3 of mod of x, then the graph would have looked like this, right? What about 3 of minus of mod x? What about 3 of minus of mod x? So basically at x is equal to 0, this would go to 1. So if there is a negative power, then and x is like always going to be positive, this whole thing, let me highlight it. This whole thing is always positive and there is a negative power, right? There is a negative power. So for a very large numbers, that would be tending to minus infinity, which would eventually reduce it to 0, right? So the graph would actually be something like, yeah, let's say here it is 1 and it decreases, right? What about the graph of this thing? So you can make the graph of this thing very easily. I'll show you the trick. So first let's make the graph of mod of x. It looks like this, right? Now basically you have to make the graph of minus of mod x. Now first we make the graph of this thing, then we make the graph of this thing. Okay, so minus of mod of x, you simply make this. Now you add 2. When you add 2, this would at x is equal to 0, this would be value 2, so this would simply shift along the y-axis, right? And now you use a mod again. So when you use a mod again, so this is the graph of 2 minus mod x. Okay, 2 minus mod x. Now I have to make the graph of 2 minus mod x and the whole mod, right? So basically when you take the mod, then what happens? That you can't have the negative values, right? So nothing will happen, only this part will get like this. So eventually the graph becomes like this, right? And this was our LHS part. So this is the graph of the LHS and this was the graph of RHS. So if you see, what is the value at 0? It is 2, right? And what is the value of the RHS at 0? It is 1, right? So if you see, like, let me mark it. So that graph would come like this and goes like this, like, okay, like this. So 1 root, 2 root, 3 root, and 4th root. So there are 4 roots. So that was the wizard method. We simply have to check how many times, what are the places, and how many times are these two graphs cutting each other. Okay, so you can comment that which method you liked, and what were the learnings you got from this video. Thank you for watching.